Good morning to one and all. We are from Sri Vishnu Engineering College for Women, Bhimavaram. As a part of Assistive Technology Lab, we are going to do the project named Voice Activated Dental Wheelchair. We are the team of 5. Myself, P. Snehapriya, Tulsi Bhagyalakshmi, Nagamani, Sri Manvita, Saranya. Coming to our project guide, he is Mr. A. Narayan Kiran sir. Coming to the motivation plays a major role in doing this project. The main crux of Assistive Technology Lab is client visit. We went to the client visit and met some of the physically challenged people and interacted with them to know their problems that they are facing in their life. In India, there are about 80 million people with various disabilities. Among this population, about 18.4 million people suffer with locomotive disability, 32.8 million suffer with various physical disabilities. Among them, nearly 4% are dental doctors. Hence, the idea of voice-activated system emerged to make physically challenged people independent to operate the dental chair. Coming to the objective, we consider one of the problems of the physically challenged people is the physical movement of their body. As they cannot freely move, they need the aid of the wheelchair. But it will take more strength to move. So we present a collision avoidance system for powered wheelchairs used by people with cognitive disabilities. Coming to the problem, in noisy conditions, speech module is unable to detect and perform the voice commands correctly. Noise occurs when 2 or more people speak together and also due to external environmental conditions. To overcome this disadvantage, we are using a speaker-dependent voice recognition module as shown here. When 2 or more persons speak at the same time, it will only recognize the person's voice. Coming to the software equipment, in our project, we contains 5 commands, that is up, down, forward, backward and stop conditions to move the chair. Firstly, let us check one of the condition. You can see here the default case which we gave 0, 1 as input in port B. Here in our software we take port A, B. Here you can see port A, B, C, D. We give port D and port C as input. Port B will be the output port. Firstly, in one case, we give 08 as input in port D. When we give 08 as input in port D, 04 will be occurred, 40 will be occurred as output in port B as we gave in the program in the software. This output will be occurred until we give 02, which is the stop condition in port D as input. Similarly, for other commands also we can write this program. Now let us see for down condition. Let's give 10 as input in port D. When we give 10 as input in port D, 50 will be occurred as output in port D. This output will be occurred until we give the stop condition which is 02 in port B as input. Similarly, the default case will be occurred for every case. Let's see one more case. We'll give 11 as input in port B and the output will be occurred as 55 in port B. As the LEDs are glown 5 and 5, it's 55 in port B. This output will be occurred until we give the stop condition which is 02 as you seen for the above all conditions. Similarly, we can write for many more commands like this. This is the software implementation that we have done. Coming to the hardware implementation, this is the PIC microcontroller, and this is the driver, and this is the relay. Here we use two LEDs. When we give input, the one LED for one particular case among those which we gave in software. In this PIC microcontroller, the program is completely dumped. When we give one of the case, the LED will be glown continuously. Until we give the stop case, the LED will be glown. Now if we give the stop case, this LED will be off and this will be on. In this way, for all the commands like up, down, forward, backward and stop conditions, this hardware implementation will be done using the relays. Thank you.